For centuries, scientists have puzzled over one of history's greatest mysteries. Where did the first Americans come from, and how did they get here?
For decades, the genetic history of the Americas was portrayed as a seamless narrative. The first humans crossed the Beringia land bridge from Siberia to Alaska, then gradually spread southward, giving rise to the indigenous cultures we know today. But between 2020 and 2025, a series of ancient DNA studies forced scientists to redraw that map entirely. Genetic sequences recovered from South America spanning Colombia, Brazil, Patagonia, and the Andes reveal a complete disruption. Entire populations that once thrived here left no trace in the genetic makeup of modern indigenous peoples. In Colombia, the 6,000-year-old Checua population belonged to a genetic lineage never before documented. In Brazil, the genomes of the Lagoa Santa people bear no connection to any surviving groups. Data from Patagonia and the Andes echo the same pattern: total genetic replacement, without evidence of conflict. The journal PNAS describes this phenomenon with a haunting phrase: replacement without conflict. If not war, if not mass migration, then what caused these ancient lineages to vanish entirely from the genetic record? For much of the 20th century, the Bering Land Bridge hypothesis stood as the cornerstone of American anthropology. It held that all indigenous peoples descended from a single population that crossed the icy bridge some 15,000 years ago. Archaeological evidence, stone tools, and linguistic studies seem to corroborate this story: a single wave of migration, splitting into two genetic branches, Northern Native American and Southern Native American, then spreading across the continent. But newly sequenced ancient DNA has shattered this notion of continuity. Analysis of 21 skeletal remains from the Checua population on the Bogotá Altiplano revealed genomes that belong to no known genetic branch. This was an isolated population, thriving for millennia, only to vanish from South America's evolutionary chain. In Lagoa Santa, eastern Brazil, 9,000-year-old genomes display morphological and genetic traits utterly distinct from the region's modern inhabitants. In Patagonia and the Andes, HLA data reveals strikingly low immune diversity, followed by the sudden appearance of new genetic lineages within just a few millennia, a hallmark of population turnover. A complete genetic replacement. These findings cannot be explained by gradual migration or natural interbreeding. They point to a rapid, radical process unfolding simultaneously across multiple regions, a cycle of loss and replacement that erased entire ancient South American populations. The question is no longer who first reached the Americas, but what erased those who came before them. For much of the 20th century, archaeologists and geneticists believed the peopling of the Americas was a story of unbroken progression. Every piece of evidence was arranged to support a single model Beringia to continuous southward expansion. According to this framework, ancient humans from Siberia crossed the Bering Land Bridge around 15,000 years ago, then diverged into two major branches: Northern Native American NNA ancestors of North America's indigenous groups, Southern Native American SNA, the root of Central and South America's native peoples. This model described a seamless genetic flow, uninterrupted by replacement or disruption. But ancient DNA data collected over the past decade tells a radically different story. In 2025, researchers from the University of Tübingen and the National University of Colombia published analyses of DNA from Checua remains on the Bogotá High Plateau. Their genomes belonged to neither the NNA nor SNA branches, but formed a distinct, previously unrecorded lineage. The Checua people lived in isolation for at least 6,000 years before disappearing entirely from the region's genetic map. In eastern Brazil, the 9,000-year-old Lagoa Santa skeletons revealed equally anomalous genomes. Their mitochondrial DNA matches no modern indigenous population, despite sharing the same geographic region. Both discoveries dismantle the assumption that all South Americans share a single origin from a northern migratory group. Studies in Patagonia provide further evidence. Ancient genomes from the region reveal haplogroup U2E, a mitochondrial lineage that existed briefly before vanishing completely. No modern population carries this variant, signaling a dead genetic branch, an extinct population. In the Andes, HLA human leukocyte antigen data indicate a sharp decline in immune diversity, a clear marker of an evolutionary rupture, where entire populations were either replaced or subjected to severe genetic bottlenecks. When combined, the studies from Colombia, Brazil, Patagonia, and the Andes converge on a singular conclusion: there is no genetic continuity between ancient and modern indigenous populations in South America. This forces a re-evaluation of the entire Beringia to southward expansion framework. Instead of an unbroken lineage, the genetic history of the Americas resembles a fractured chain where genetic branches form, persist, and then vanish. If the old map was wrong, what needs to be redrawn is not just the journey of humanity, but the very mechanisms of their evolution and survival in prehistory, with the old genetic maps debunked. The next question looms: what caused ancient groups like the Chekwa and Lagoa Santa to vanish entirely from humanity's genetic lineage? The answer may lie in the very trait that allowed them to endure for so long: genetic purity. Geneticists call this the paradox of purity. Small, isolated populations can maintain stable genetic traits for millennia, but this very isolation strips them of biological adaptability. Data from ancient DNA in the Andes and Colombia reveal extremely low HLA diversity, the gene group governing immunity, Cell 2023. This meant that a single new pathogen could devastate an entire community, as they lacked the cross-immunity to resist. Archaeological evidence bolsters this grim picture. Chekwa skulls excavated in Bogotá show chronic jawbone infections, dental abscesses, and signs of malnutrition. Pelvic bones from Lagoa Santa reveal deformities linked to endocrine and reproductive disorders, JS reports 2022. These findings paint a portrait of populations under immense biological stress pressures that a closed genetic system could not overcome. Scientists liken this to the genetic bottleneck seen in Neanderthals, a once thriving population, weakened by excessive genetic narrowing, leading to diminished resilience and eventual extinction. For the Chekwa and Lagoa Santa, the pattern is eerily similar. Prolonged geographic isolation preserved their genetic stability, but locked them out of evolutionary adaptation. Researchers describe these as genetically closed populations, where each generation reproduced only within a small community. When environmental shifts or diseases struck, they had no opportunity to exchange genes with other groups to produce adaptive variants. The result: within a few generations, entire genetic lineages were erased from the region's gene pool. The purity once seen as a hallmark of pristine, ancient cultures became the very cause of their disappearance. The question scientists now ask is not how did they live, but how did they die genetically? Having ruled out warfare and large-scale migration, scientists are left with one possibility: a natural or biological event of continental scale, something capable of collapsing multiple populations simultaneously, without leaving clear physical traces. They call this hypothesis the genetic reset event. When cross-referencing geological and genetic data, independent research teams identified a striking temporal pattern. Between 4,000 and 2,000 years ago, the Andes, Patagonia, and Central South America experienced a period of severe environmental upheaval. Sediment cores from Laguna Blanca in southern Bolivia reveal a spike in beryllium-10, GRL 2023, an isotope linked to intense atmospheric disruption from cosmic radiation or extreme solar flares. Within the same sediment layers, researchers found charred carbon particles and silicate micrograins, hinting at an anomalous high-energy event, possibly tied to solar radiation or a small celestial impact. Genetically, the data align with this timeline. HLA diversity. The genes regulating immunity plummeted simultaneously across the Andes and Patagonia. Research teams in Germany and the United States noted mutations linked to inflammation and energy metabolism, suggesting widespread biological stress, not localized change. No evidence of conflict or population movement exists in the cultural layers of the same period. Ancient settlements from Colombia to Chile show abrupt interruptions in occupation, unfinished tools, abandoned signs of daily life. Yet there are no widespread burn marks, no arrowheads, no traces of battle. If death came, it arrived silently and universally. Geobiologists propose a bold hypothesis: an extreme solar flare weakened the ozone layer, increasing ionizing radiation and triggering genetic mutations and reproductive disorders in small, already gene-poor populations. Isolated groups like the Chekwa, Lagoa Santa, and Patagonian peoples were the first casualties lacking the genetic recombination needed to recover. Within a few generations, these communities vanished from the evolutionary chain, leaving a void in the genetic map of the Americas. Around 2000 BCE, as ancient populations like the Chekwa and Lagoa Santa faded from the genetic record, scientists detected the arrival of an entirely new group. DNA sequences from the same regions reveal a total replacement. No trace of the ancient genomes remains, replaced by a new genetic profile linked to northern origins, the Chibchan people. Studies published in Science Advances 2024 confirm that Chibchan groups migrated from Central America to the Colombian highlands, occupying lands once held by the Chekwa. Archaeological sites from this period reveal a new cultural layer, marked by Herrera pottery, distinct in its firing techniques, color schemes, and patterns, utterly different from earlier artifacts. This signals not just a new technology, but the arrival of an entirely new culture. Biological evidence supports this replacement. Genetic comparisons between the ancient Chekwa and later Herrera peoples reveal no shared ancestry. The Herrera genomes show higher genetic diversity, particularly in loci tied to immunity and energy metabolism, suggesting a population that had undergone extensive gene mixing, better equipped to adapt to local climates and diseases, precisely what their predecessors lacked. This cultural shift mirrors the genetic one. Archaeological traces from the period reveal a clear ecological and social transition from hunter-gatherer lifestyles to settled agriculture. Stone tools gave way to polished hoes. Pollen from cultivated crops appeared in sediment samples, and settlements began to reflect more complex social organization. All point to a new population reshaping the human ecology of the Andes highlands. Remarkably, this process shows no signs of violence. There is no evidence of warfare or large-scale cultural conflict. The replacement appears to have occurred naturally, a healthier, more diverse, and populous group gradually dominated a region weakened by a genetic crisis. Biologically, this was a recovery of the gene pool after the genetic reset. After the isolated ancient groups went extinct, the region became a genetic void filled by northern migrants. Within a few generations, their new genome became the foundation for later civilizations, notably the Muisca, one of the most organized societies in the pre-Columbian Andes. Thus, the Great Replacement was not an invasion, but a natural biological succession. These successors brought adaptability and resilience, ushering in a new evolutionary phase for humanity in South America. The lingering question is if the ancient peoples were erased by a biological reset. What allowed these newcomers to survive and thrive? The answer may lie in the very mechanisms that enabled them to surpass the evolutionary limits of their predecessors. The latest data from over 5 years of research, published between 2018 and 2025, cement an undeniable conclusion: total genetic replacement was not confined to Colombia or the Andes, but spanned the entirety of South America. Geneticists call this the genetic reset, a simultaneous genetic reboot occurring between 4,000 and 2,000 years ago. A genetic map published in Nature 2025 marked a turning point in bioarchaeology, when ancient DNA from Brazil, Patagonia, Colombia, Peru, and the Andes was plotted on a single timeline. Researchers uncovered an eerie synchronicity within 2 millennia. Ancient indigenous populations were entirely replaced, leaving no genetic trace in modern humans. Not a single ancient haplogroup persisted into later periods. The journal PNAS 2025 labeled this phenomenon genomic discontinuity across the southern continent, from Colombia to Patagonia. The same story repeats: one population vanishes. A new one emerges, carrying an entirely different genome with greater biological diversity and adaptability. This proves the genetic reset was not a localized event, but a continental-scale biological process, potentially driven by environmental or cosmic forces. Scientists are now testing a multi-regional collapse model, a hypothesis suggesting this event struck nearly simultaneously across South America, wiping out small, isolated populations while larger, more diverse northern migrants filled the resulting void. A natural genetic and ecological process replacement not through war, but through evolutionary limits. The genetic reset does more than uncover a forgotten chapter of human history. It issues a warning for the present. Geneticist Lars Fehren Schmitz, University of California, Santa Cruz, once stated, "If this happened once, it can happen again." That warning grows more urgent by the day. In the 21st century, humanity faces parallel phenomena: declining genetic diversity in urban populations due to globalization and genetic homogenization, the loss of 90% of agricultural diversity in a single century, leaving ecosystems vulnerable to disease, global pandemics exposing the fragility of populations with high genetic similarity. What happened to the Chekwa and Lagoa Santa is not a distant relic. It may foreshadow a scenario that could repeat if humanity continues to erode its own biological and genetic diversity. The genetic history is not over. It merely awaits the right conditions to replay. If a reset once erased entire genetic lineages across South America, then in our modern era, marked by climate change, biotechnology. And global population density, another genetic reset on a global scale, is entirely possible. As scientists pore over ancient genomes abruptly severed in the genetic record, they are not merely tracing our ancestors. They're gazing into a mirror reflecting the biological limits of evolution and the fragility of life against natural upheavals. For if the genetic reset happened once, the final question is no longer, why did they vanish? But when will it be our turn?